Good afternoon, everybody. Very sorry for the delayed start. Some issues starting out. Everybody can hear me? Can see the screen? Let's make sure.
Yes, sir. Yes.
All right. Yeah, sorry for the late start today. But you know it is on a Saturday. A lot of things to do. And I actually got delayed today. But as we always say, better late than never. And then the session is recorded for those who cannot attend. So just wanted to take the opportunity today to revise what we did on Sunday. All right. And we do it in the form of basically just doing some of these questions that I sent for you to do. So that those of you who did them and you made some mistakes, you will learn from them. Those of you who did not do the questions, you still can go and do the questions even after I do them. Bottom line is that you must know how to do these questions and understand. I always say there are multiple ways to do questions, right? And I use a method that is the easiest way. But if you know how to do these questions another way, you learn it somewhere else, and you're good and comfortable with that other way, then that's fine. Just make sure you get the questions right. All right. So that is always the plan. All right. So this is the first question that I sent you. That's on the screen now. It's actually the January 2021. You can see it's the January 2021 on the title there. Exam paper. And this is number 4 or 5. Let's see. This is number 5 on this paper. And we're looking at 5B. All right, is a question, is a ratio question. It's a pie chart, so it's almost like there's some statistics twined up into it. So we can use a statistics approach for some parts of it. In particular, statistics related to pie charts. But then this question can be done solely as a ratio question. All right, and as I always said, ratio questions with ratios and proportions, those questions can be done primarily by simply multiplying and dividing by values to get the information that you want. All right, in the main, that's what we do. Multiply and divide by values to get the information that we want. So that is the approach that I primarily use. All right, so let's look at this question. So this question says, a group of students wrote a physics exam. Each of the students achieved a grade 1, a grade 2, a grade 3, or a grade 4. So I guess this is a standard grading system for CSEC, right? For CSEC. So grade 1 to 3 will be passing grades, and grade 4 will be the failing grade. And those are the grades attained. It says the pie chart below shows the results. So they have placed the results in a pie chart. So those who get grade 1 are in that sector of the pie chart. Those who got grade 2 are in grade 4, are in that sector of the pie chart. Those who got grade 2 are in that sector. And then they gave us more information in terms of who got grade 3. So based on this, 39 students of the total got grade 3. And the 39 students is occupying a sector angle of 117 degrees. What we know is that the total angle inside here is 360 degrees, and 360 degrees would correspond to the total number of students. So we're 117 degrees corresponds to 39 students. 360 degrees will correspond to the total number of students. All right, you can look at it that way, because they'll be in the same proportion, the same ratio. All right, so we can do this as a ratio question, and there's actually some ratio in it. And it says it here, 39 students achieve grade 3. That is what is here. And it says that we have to determine the total number of students who wrote the exam. So because we're on the topic of ratio, I'm going to do it, I'm going to use a ratio approach to it. What did I say? I just said we can use the angle and use them in this equal proportion. So 117 degrees is the angle corresponding to 39 students. You can put that as a ratio. And to get the total number of students, we want to see what 360 degrees would be. And again, I'm going to use the approach where I am multiplying and dividing by values. All I'm doing, multiplying and dividing by values. That's the approach that I want to use. I'm going to set it up like this. Based on this information, 117 degrees. You can put 117 degrees to 39. That is the angle to the students. Let's set up like that. The angle to number of students. So this is angle, sector angle to number of students. That's right, students, meaning number of students, right? That's the ratio that I've set up. And I know that when the angle reaches 360 degrees, the number of students will be the total number of students. So all I need to do now is extend this ratio or increase this ratio such that this side, the angle side, becomes 360. How can I do that? I can find out what value I need to multiply this by for it to reach 360. And then multiply this by the same value. But what I can do, I can bring this down to 1 first, 1 degree, and then multiply it up back to 360. That's one approach that I can take. And in fact, that is the approach that I'm going to use. To bring it down to 1 degree, I have to divide the ratio by 117. Because it's this side I want to reach 360. You know? So I'm going to divide the ratio by 117 first. So because I want this side to go down to 1. When I divide by 117, and I don't have to work out at every line, I just need to leave final calculation for the final step. So when I divide by 117 degrees, this side comes down to 1 degree to, this becomes 39, sorry, this becomes 39 divided by 117. But I really need this side to become 360. What am I going to do next? I am now going to multiply by 360 so that it will get up to 360. When I multiply by 360 again, I have to multiply each side of the ratio by 360. When I multiply this side by 360, I'm going to get 360 degrees, which is what I want. To this now is going to be 39 over 117 times 360. Whatever that works out to now is the total number of students. And I think this worked out to be 120. And so 120 is the total number of students there. So total number of students is 120. All right, so total number of students equals 120 students. All right, let's go back to the pie chart now with that information, because the more information you find, you want to start to indicate it on the pie chart. So let's look at this now. So we have 39 students here, and the total all around is 120 students. All right, so it means that over this side, it means that over this side, let's put down in red. These three that we don't know the number of students, those three add up to a total of 120. Here is 120 students minus 39. So these 3 grades were obtained by this number of students. 120 is everybody minus the 39. No, 39. No, 120 minus 39 is 81. 81 students. So 81 students occupy those grades. Right? So the total number of students getting grade 1, 4, and 2 is 81. 81 students. All right. All right. That's between these 3. So I'm put arrows on them. Those 3 add up to 89 students. All right, let's continue. Down here now, it gives us some additional information. It says the ratio of the number of students who got grade 3, 2, and 4. That's the same section over here now that we don't know here now. 3, 2, and 4. 2, let me look at it again. Let me look again. Yeah, 1, 2, and 4, right, over here. Grade 1, 2, and 4. They're telling us that the 1, 2, and 4 students are now in the ratio, 2 to 4 to 3. This is the 81 students, you know. I remember, this is 81 students. We just wrote that out a while ago. So it means that 81 students are in the ratio 2 to 4 to 3. That's what it means. It says a student passes, the students pass the exam if he got a grade 1 to 3, as we know. It's asking us about how many students passed the exam. So we need to know how many students got grade 1, how many students got grade 2, how many students got grade 3, and add them up. Or we can find how many students got grade 4 and subtract that from the total number of students. Remember, those who got grade 4 would have failed. If you want to know how many passed, you can find how many got grade 4 and subtract it from the total number of students. All right. So they gave us this ratio for grade 1, 2, and 4. So let's use it up. All right. And I will know something about the total of that ratio, the actual total. So I'm going to extend the ratio to show total. So the grade 1 to grade 2 to grade 4 is in the ratio 2 to 3, 2 to 4, sorry, to 3. But because we know something about the total, I'm going to extend this total to show the total of this group. All right, grade 1, 2, and 4. Let's just call that group. Let's just call this group for now. I don't want to say the total number of students. Total of that group. Total of this group. And the ratio, in the ratio form, the broken down format, that total would be 9. Because if I add this up, you're going to get 9. So all this now is the broken down comparison of the students who got 2, 1, 2, and 4. And because we know the total, we have extended the information to include the total of the group. And it is 9 parts. But we know that the actual is 81. So what it is, we want a line now of values to show the actual. But because we know that the total is 81, we're going to compare these two values now. How do we get this total 9 to become 81? By multiplying it by 9. So I want this side to show the total of 81. I have to multiply by 9. It is now 9. 9 times 9 is 81. So I have to multiply by 9. When I multiply by 9, this becomes the 81 that we know that it is for that group. Multiply this by 9, we're going to get 27. Multiply this by 9, we're going to get 36. Multiply this by 9, we're going to get 80. So we now know the total number of students. Remember, those who got grade 3, you can write up here saying, those who got grade 3 was 39 students. So the students who passed the test will be those who got grade 3 up here, those who got grade 1 down here, and those who got grade 2. Those are who passed the test. So if you add up those, you get who passed the test. So number who passed would be equal to 39 who got grade 3 plus 18 who got grade 1 plus 36 who got grade 2. And that works out to be 93. 93 students. Another way to do it here, let's call it R, is to take the total minus those who failed. Total minus those who failed. So remember, 27 of them got grade 4. So the other way to do it is to say it's a total minus who failed is the number that passed. Passed equal this. Right? So the number that passed would be equal to 120 total students minus 27 who failed. And that would also work out to by 93 students. 93 students. That is it. Everybody good at that? Everybody okay?
Yes, sir.
Yeah.
All right, good. So using this ratio approach to do the question, all right? All right. The next part says, determine the angle sector representing grade 1 in the pie chart. All right. Again, we're going to do it as a ratio question. You don't have to do it as a ratio question, but I'm deliberately doing it as a ratio question. So what do we know? We know that 39 students corresponds to an angle of 117 degrees. Or again, you could go back and say 120 students corresponds to 360 degrees. Either one, you can use this or you can use this one. Doesn't matter. But this is the total and that, right? So we know that. So we can work with the total. And we want to know the angle for grade 1. But remember now that the number of persons who got grade 1 is 18. So we're going to take the ratio and extend it down to 18 and see what 18 would be. So let's start this way. Let's say we know that students, I put angles to students then. Oh, they want the angle. So I want to say students for angle, we're setting up like a ratio. Let's use the total. It's 120 to 360. I don't have to use the 120 because I've used the 117 and the 39 as well. Right? 39 students are 117 degrees. But I'm going to use the 120 students corresponds to 360 degrees right now. And I want to know what 18 students correspond to. 18 students got grade 1. So I need this side of the ratio to go down to 18. All right? So how can we get it down to 18? We can divide it down to 1 first and then multiply it back up to 80. We can divide it down to 1 and then multiply it up back to get the 18. And we're doing the same multiplication and division on that side. All right? So to get it down to 1, we have to divide by 120 first. So I'm going to divide the ratio by 120 first. So divide by 120. So that this becomes 1. So the ratio then will become 1 to, if I divide this by 120, I'm going to get 3. That's correct. But I give it that. So it's 1
Yes, sir.
to 3. So 1 student is 3 degrees. But I really want 18. So to get the 1 to become 18, I'm now going to multiply by 18. And I'll see what 18 degrees corresponds to. So multiply this by the 18. I'm going to get the 18. But I also have to multiply this by 18. When I multiply that by 18, I get 54. And so this is the answer. So grade 1 would occupy an angle of 54 degrees. That's it. The angle is 54 degrees. So therefore, the angle that I want is 54 degrees. Or the grade 1 angle. Grade 1 angle is 54 degrees. So maybe if I do this question another time, if I do this question with the topic of statistics, my approach to it might be different. Because we're doing ratio, proportion, and so on. I'm using that approach where I'm seeking to just multiply and divide by values to get the information that they want. All right, that ends this question. But okay with that? Very good?
Yes, sir.
All right, beautiful. All right, next question I'm gonna do is another one that I sent to the group. Let me see which one it was. I sent January 2016 people to the group. So let me look at that one now. January 2016. January 2016. Right here. January 2016, number 4. So you see January 2016 exam paper. We're looking at number 4 for practice. But if you got something wrong, you need to redo the question. All right. Anything you got wrong, once you got something wrong on the question, you do over the whole question. Don't just correct the part that you got wrong. Do over the entire question. All right. Oh, this is it, number 4. All right. So this is a map and scale question. All right. And again, there are multiple ways to do these questions, but wherever possible, I'm going to use a ratio approach to it. Because after all, they will give you a scale, and a scale really is a ratio. All right, it says the diagram below shows a map of an island drawn on 1 centimeter grid. So it means that each of these is like a box. It's 1 centimeter by 1 centimeter. All right, on that grid. That's what it means. All right, 1 centimeter grid. All right, or 1 centimeter squares. It says, state in centimeter the length of L on the diagram. That's the distance across here, L to M. So all we need to do is count how many of the boxes are there. So it's 1, 2, 3, 4, 5, 6, 7, 8. So it's 8 centimeters across here because you go across 8 boxes to go from here to here. All right, or 8 squares. So it's 8 centimeters, easy. So the answer for this is just 8 centimeters. It says estimate by counting squares the area of the map shown in the diagram. It's 1 mark for it now. So you really shouldn't be doing a lot of work. So I think some persons actually proceed to the count of these boxes. Just count them off. Just count them off. And try to count off the whole ones. And then look how many half ones they have. And count them off, right? Something like that. Just count off all of those. Some persons can do like a rough calculation. I use a rough calculation method and recognize, for example, that would basically have a rectangle inside here, at least down to here. I have covered a good bit of it with that. This is a 1, 2, 3, 4, 5, and a 1, 2, 3, 4, 5. So you cover 25 squared inside there already. 25. So inside here I already have 25. And you start to add the extras on the outside here, right? So you have approximately 4 more. Right? So this you can count, for example, this one's a whole box. Start to balance out itself. Right? Because if you count this is a whole box, then you can ignore this little piece. Because like these 2 pieces would kind of balance out each other. Where one is outside and one is inside. All right, so that's 25. This is 26, 27, 28, 29, 30. Again, here we kind of balance out here. All right, you can count this as 31, 32, 33. All right, and then we have these over here to count: 33, 34, 35. I can ignore this piece because it balances out the piece that we're missing from here. All right, so call this 36, 37, 38, 39, 40, 41. These 2 pieces together make 42. 42. So these 2 together, I come to 42. Then down here is 43, 44, 45, 46. And then this one, you can leave out this because here now, we basically account for the piece here that's not included. We can leave out that little piece. So I would say maybe about what would I count? 46. And it's basically what you get, CSEC will give you the marks for what you get. And work with what you get. And it's an estimate. So everybody don't necessarily will get the same thing. But personally, I don't like that approach. Right? I like when I'm looking for shapes. So right there I have 46 so far, right? So I'm saying it's 46. Right? Looking at 46 to me so far. Right? That's assuming that the calculation in it was right. What did I do? I did this and that and that and that to start. That was 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Good. So I'm saying it's 46. But I like an approach where I look for shapes in it. Like triangles, rectangles, and I try to calculate. But you're still counting. So for example, I would know that overall it fits within a big rectangle like this. One approach you can use, you know, and calculate that whole area there. So, and then we're going to subtract off these pieces. Like here, subtract off that piece, subtract off that, subtract off that, subtract off that, subtract off those sections. And maybe if you look at these sections, you can estimate some basic shapes. Right? So what is the outer red dimension firstly? The outer red dimension would be a 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 by 1, 2, 3, 4, 5, 6, 7. 9 by 7 overall first. And then I want to subtract off the pieces that I have inside. Again, I can go ahead and multiply these two and get the total area. And you're subtracting off some of these inside here. Subtract them, right? It's another approach you can make, you can use. Let's do a calculation method and see how close we will come to the 46 that I have. And I saw different answers from different persons sending in the group. I don't remember what values all they got, but the person's got different values. All right. So far, so good, guys. Understand what the approach is so far?
Yes, sir.
All right. So we have 9 times 7 first. That is 63. And we're going to subtract some areas now, right? All right. Let's see if we can estimate some areas to subtract. So right here looks like a triangle. Right here. Up to about here. So to me, that looks like a triangle. We can estimate that as a triangle and subtract out that area. What's that triangle? The height is 2 and the base is 1, 2, 3, 4. The base is 4. So if it was a square, it would be 4 times 2 is 8, but it's half of that. So this area is actually 2. This area is 2. So like this has 2 in it, right? 4 times 2. So it's actually 4. Like this is 4. So I'm gonna call this as 4. Let's put the value inside here. Like we have 4 in there, so, right? So let me leave this 4 and this 2. Then we have this now. Here also looks like a triangle. Let me see, right here looks like a triangle almost. But we're giving away a piece inside here. So I might not want to go for a full triangle. I might just count it as 1, 2, 3 squares. All right, 3, because this piece here that is not included is taken care of out here. All right, I'm gonna call this 3 squared over here, so 3. So 4 over there, so 3 over there. So up here now, am I subtracting? 1, 2, 3, 4. It's like 4.5. But this little piece, I'm not counting it. So I can call this 1, 2, 3, 4. Not counting this little piece either. So 1, 2, 3, 4. Let's call this 5. All right, let's call over here so 5. So 4, 5. And then over here now, we have 1, 2, 3, 4. If I don't include this, that takes care of that. 1, 2, 3, 4, 5. I'm not going to include this. That takes care of that. 5, 1, 2, 1, 1, 2, 3, 4, 5, 6. Let's call over here, so 6. And as I said, it's what you get. Right? It's an estimate. So I'm calling over here, so 6. So it's going to be 63 minus these figures. 63 minus these figures. So 63 is the total. I'm subtracting these figures now from 63. All right. So those figures add up to what? This and this are 10 and 8, 18. So it becomes 63 minus 18. So I'm doing 63 minus 18. What I work out to? How to get for that? 45. So you're close enough to the 46. So when you work with it, good enough. Let's say I'm going to work with the 45. All right. I'm going to keep on working with the 45. But as I said, anything near that you get, CSEC will basically give you your marks. But when they give you shapes that you know for sure that you can use calculation on, you do it. All right. I'm telling you that from now. All right. Let's put that 46 for the small piece that we left off. Right. So 45, I'm going to approximate it up to 46 for the pieces that we left off. So I want to say approximately 46 centimeters squared. Let's work with the 46. 46 centimeters squared. All right. All right. We're going to approximate it up to 46 because of a small piece that we left out. There were some small piece that we left out. So approximating up to 46. And this is one mark, so, I don't think it really should require so much work. So you can do a rough count if you want, and so on. Some people teach count halves and so on, right? And add it up. But I prefer the question where you can identify particular shapes and calculate. I prefer do it that way. But let's work with the 46. Then it says now, on the island, the actual distance of LM is 8 kilometers. It says complete the following statement. 1 centimeter on the map represents what? So we basically want to take what they gave us. So the 8 centimeters that they gave us, remember now, the LM is 8 centimeters on the map, and they're telling us now that it is actually 20 kilometers. And I want to know what 1 centimeter is in kilometers. So we can start with that ratio that we know. Right? So look at it this way. The map to the actual is 8 to 20. Let me write the centimeters. Is 8 centimeters. 8 centimeters. The unit is important as well. To 20 kilometers. And you want this to become 1. So let's divide through by 8. You want it to become 1. You divide through by 8. And you see what 1 is. So it becomes 1 centimeter to 20 over 8 kilometers. Whatever this workout is, what is coming here. What to get for that? That's 10 over 4. What is that?
2.5.
2.5 kilometers. But go to that. But understand the calculation?
Yes, sir.
All right. The next part now says we have to write the scale. Write the scale in the form 1 to some number. You know what this means? This means no unit. Don't want any unit. So how to get it with no unit? It means you have to bring the 2 sides to the same unit of the scale. All right? We're going to bring the 2 sides to the same unit. So like we're going to have to turn this 2.5 kilometers into centimeters. So right now is 1 centimeter to 2.5 kilometers, So right now we have 1 centimeter to 2.5 kilometer. Remember I told you, you can multiply and divide a ratio by any constant value or any constant unit of measure. If you don't want the ratio to have a unit of measure in it, we make sure that both sides have the same unit of measure. So we have to take this 25 kilometers over here, 2.5 kilometers, and turn it into centimeters. How can do that? You can turn it into meters first and get 2.5 times 100, it is now meters. And to get this meters into kilometers, I'm going to multiply it by 1,000. That's how many centimeters it is. 2.5 kilometers, carry to meters first. And after we carry to meters, no, sorry. Let me do that over here. Carry to meters first by multiplying by 1,000. Sorry. So this is carrying it to meters. So this is the amount of meters it is now, you know. But to save the calculation, I can just go now and multiply the meters by 100. And you get centimeters. But if you know that 100,000 centimeters make a kilometer, then you could just multiply by 100,000. This is still 100,000. You could do it as well. All right, but I'm just taking it in stages. So I'm saying multiply it by 1,000 first. If you have a 2.5, you multiply it by 1,000. Got it again. If you multiply it by 1,000, that is now meters. And to go from meters to centimeters, you multiply by 100. And it is now centimeters when you do that. So by that calculation, I'm going to give you centimeters. All right? Centimeters. And so now we can just write out what this is and drop the centimeters. So the ratio becomes 1, 2. So like we divide them by the centimeter now. Divide out the centimeter. Remember I told you, you can divide by a unit of measure. So I'm dividing out these 2 centimeters so that my scale becomes just numbers. How do I multiply by this? How do I multiply this by these? I have to move decimal point 5 places to the right. 3 from this and 2 from that. 5 places to the right of the move the decimal place. So it's gonna go to 2, 5, 1, 2, 3, 4. Let's check it. 1, 2, 3, 4, 5. Yes, that is correct. So that is the answer right there. This is it. All right, so it's 250,000. 1 to 250,000. As a scale without the units. But I understand that? So the x, if they ask for the value of x, that would be it. 250,000. I've seen questions already where they ask for what is the value of x. 250,000. What I go do that?
Sir, could you go over it again?
Over it again.
Yes, sir.
All I am doing is converting kilometers to centimeters. Do you understand why I have to do that? Because they're asking for the scale without units. This is a scale with values only. So they don't want the unit of measure. You have to recognize that this side is in centimeters, but this side is in kilometers. So we write it like this, we cannot leave off the units because they are not the same units. If you want to eliminate the unit, or if you want to don't write the units, you have to get the 2 sides to have the same unit. But this side is already 1. So it means that this is the unit that we want to break down, the kilometers. It's a kilometer that we want to break down. But you have to know how you go from kilometers to centimeters. And I'm taking it in stages for you. You can go from kilometers to meters first by multiplying by 1,000. Because 1,000 meters make a kilometer. Then you can go from meters to centimeters by multiplying by 100. Because 100 centimeters make a meter. A meter has 100 centimeters in it. If you want, you can go from kilometers straight to centimeters, from kilometers straight to centimeters by multiplying by 100,000. That's something you'd have to know. You get me? There's also a thing that we call for this unit of measure. Kill him there, Mr. Don't commit murder. So my kilometers is 2.5 right now. And I want it to go to centimeters. It's telling me how many places I have to move with decimal point. 1, 2, 3, 4, 5 to go from kilometers to centimeters. This second thing is telling me that as well. So if you can memorize this, then you can remember how you go from unit to unit. All right? So how I remember this from back in the day, everybody have a different way to do it. If you look in some textbook, you'll see. My one is kill him there, Mr. This is Mr. This is don't commit. And this is murder. That's how I remember it. So to go from kilometers to centimeters, you would move the decimal point. This tells you how many places have a moved decimal point. 1, 2, 3, 4, 5. 5 places to the right. And you put in the zeros in between there. You move the decimal point to the right. All right, that's what it is. To go from kilometers to meters. So if you can remember this, some people have other ways of remembering. Anybody online have a different way to say this thing?
Yes, sir.
Say it, let me hear. Let somebody hear.
Knock him down, Mr. Do commit murder.
Oh, so you said knock him down instead of kill. All right, so that's another way. So some person said knock him down. Mister, don't commit murder. But from my days in school, ours was kill him, dear mister. I think they wanted to get all the word kill out of it. And so I said knock him down. All right, but whichever way, it doesn't matter. So this you can use this thing to take it from unit of measure, between units of measure. So for example, if you have centimeter, a centimeter figure, you want a kilometer, you move decimal point 5 places to the left. 1, 2, 3, 4, 5. Look at it. If you have kilometers, if you have a figure in kilometers and you want to go to meter, it's times 1,000. Move decimal place 3 places to the right. 1, 2, 3. After I get here, I want to reach centimeter, I got 2 more. 1, 2. So this is 1,000. And this is 100. That's what I did up here. All right. But I'm using the general knowledge that people have, that a kilometer is 1,000 meters and a meter is 100 centimeters. All right. So back to this now. I want this side to become centimeter, this side to be expressed in centimeters. So I convert 2.5 kilometers to centimeters. And so I can divide off the centimeter. Because remember I said a ratio can be multiplied or divided by any constant value or any constant unit. So I can divide off the centimeter unit of the ratio. But I have to get this side to become centimeter first. So whichever way you want to use to go from kilometers to centimeters, fine. All right. Some persons know that 100,000 centimeter is equivalent to 1 kilometer. So you can multiply this by 100,000 to get centimeters. Right? You can do it that way as well. So any way you want to do it, it becomes 1 centimeter to, I'm going to move decimal point. I say I have the 2.5 kilometers. I convert it to meters first by multiplying by 1,000. This is the amount of meters that it would be, but I want centimeters. So to go from meters to centimeters, I have to multiply by another 100. And it is now centimeters. So this thing, kilometers, is now this amount of centimeters. That's what it is. Because I know of centimeters on both sides, I can divide them off. That's what this is saying. Divide off the centimeters and leave just the values. So we have the 1 now, 2. And this calculation is going to move the decimal point 5 places to the right. 2, 5, and then 4 zeros. 1, 2, 3, 4, 5. That is it. That is the answer. Okay, any better? First who asked for me to explain it over. Any
Yes,
better?
sir.
All right.
Yes, sir.
The important thing is that we wanted the 2 sides to have the same unit of measure. So we can divide it up because this scale that they want don't have any unit in it. Up here, when they asked for it, they wanted the centimeter and the kilometer. We are doing it like a ratio question, as a scale question. Map and scale, we're doing it like a ratio. And so they even bring it to us here. They bring it to us here. Right? So we're doing like a ratio question. We're just multiplying and dividing by values and units of measure. X down here now says, what distance on the island will 3 centimeters represent on the map? What distance on the island would 3 centimeters on the map represent? So basically, let's multiply this by 3, or we can multiply this by 3. As the distance on the island, I'm going to give it in kilometers, you know. All right, so when I say, okay, starting from up here, 1 centimeter corresponds to 2.5 kilometers. You want to get 3 centimeters? You multiply this by 3 because I want this side to become 3. So we're going to multiply by 3. So we're going to get 3 centimeters corresponds to multiply this by 3, we're going to get 7.5 kilometers. So the answer is this 7.5 here. Answer 7.5 kilometers. This is the answer right here. 3 centimeters. It says now, what area on the island represents 3 centimeters squared? I can do this in multiple ways for you. I'm going to do this in 2 ways for you. Let me show you a nice way to do it. So we know, watch this now, guys. We know that 1 centimeter is 2.5, right? And we know that 3 centimeters is 7.5. Another one, 3 centimeters squared. Look at this nice way to do it. I'm going to do it 2 ways for you. I'm going to do it where we get the area scale and use the area scale, but I'm going to do it with the 3 centimeters. Watch this now. The 3 centimeters squared is the same as 3 centimeters times 1 centimeter, you know. That's what it is, you know, on the map. This is on the map. A 3 centimeters squared can be seen as the product of 3 centimeters times 1 centimeter. All right? We're going to extend this now to the land, to the island. So on the island, this 3 centimeter is 7.5 kilometers. So the 3 centimeter distance on the map is equivalent to 7.5 kilometers on the island. So I'm going to write 7.5 kilometers times. Now 1 centimeter here now is 2.5 kilometers on the island. So I'm going to write 2.5 kilometers. So that area here, which can be broken down into this times this on the map, becomes this times this on the island. So write that out and get the answer in kilometers squared. Okay, kilometers squared. This kilometer times this kilometer give me this kilometer squared. I just need to work out now the 7.5 times the 2.5. I want to get for that. Somebody write that out for me. 7.5 times 2.5. What again?
Sir, 18.75 kilometers squared. 0.75.
18.75 kilometers squared. That is the area. And I just chose to do it that way. I'm going to do it another way. We'll go from a distance scale to an area scale. I'm going to use that approach over here now. So this here is a distance scale. All right. So let's look at it this other way. And I'm going to do it another way. So the distance scale is 1 centimeter to 2.5 kilometers. This is the scale for distance. All right. This is the distance scale. Distance scale. To go from a distance scale to an area scale, what you do, you square both sides. You square this side and you square that side. That's all you have to do. Square both sides. So I'm squaring both sides. Square both sides. When I square both sides, I'm going to get the area scale, a scale for area. This side, when I square it, I square the 1, I get 1. Same way. Square the centimeter, I get centimeter squared. 2. 2. I have to square the 2.5. So it's 2.5 squared and square the kilometers. Kilometers squared. So this is the ratio now, you know. This is the scale, not the ratio, the scale for area. This is the area scale. And I can work out what this value is, 2.5 squared. I can work that out. I don't need to, but I can work it out to get it absolute value for it, 2.5 times 2.5, that's 6.25. So the scale is 1 centimeter squared. The scale for area is 1 centimeter squared to 6.25 kilometers squared. In order to have the scale for area, I want to know what 3 centimeters squared is. Remember, I know this is the map side, this is the map side of the scale, and this is the actual side of the scale. That is understood. I now want this to become 3 to see what 3 corresponds to. For this to become 3, I need to multiply this whole ratio by 3 now. If I multiply this side by the 3, I'm going to get the 3 centimeters squared to multiply this side by the 3. I'm going to get the same 18.75 kilometers squared. So anyway you take it, this right here is the answer. So yeah, I gave you 2 ways to do it. But I write it that?
Yes, sir.
I think this is a nice way to do it over here. All right, so you can practice it this way as well. Let's break down the area into 2 linear dimensions, the product of 2 linear dimensions. And you write what this side is on the island, what this dimension is on the island, and what this dimension is on the island. And then you multiply them back in. Remember, the 3 centimeters squared is the product of a 3 centimeter length and a 1 centimeter length. 3 times 1. Right, what 3 centimeters is equivalent to is this. 1 centimeter is equivalent to this. So to get the area that this product represents, you multiply these 2. And that's how we end up with that. So this is a nice way to do it without having to find the area scale, this area scale. And the thing about it is that we had the information already to do it this way, because we knew what 3 centimeters was up here, and we also knew what 1 centimeter was up here. All right, so put them together and get this. That is it. Rather than go finding the area scale first. But if in doubt, you can find the area scale and use it. All right. Everybody good at that? But okay?
Yes, sir.
Yes, sir.
All right. One more equal better math. That finishes that question. All right. That finishes that question. So that was a nice one. I prefer the map scale diagrams where you can actually see the standard shapes and calculate them off, like the one that we did in the class the other day. But if you get this to do, you work with it. And I tell you, if you use 45, they give it a mark. They use 46, they give it a mark. Trust me, they'll give it a mark. It's 1 mark for it. And they'll give you, once you come close enough, they'll give you. Maybe somebody will get 44 up to 47. Anything in that range, they might give it a marks. All right? They give it a marks. All right. So remember, guys, the key word here is estimate. Estimate. All right, good. What was the next question I gave you to do? I gave you, let's see. I gave you another question. January 2016. I gave you May 2015 to do as well. More maths equals better maths. So I gave you May 2015. All right, May 2015. Which question I told you to do on this one again? Which question did I have to give to on this paper? Somebody tell me. May 2015.
Sir, question 5.
Yeah, question 5. So I'm sending all these past papers in a group. You can try some of the questions on it and don't be afraid. We're going to eventually do all of them on the exam conditions, but you can use them for revision, practice from them, special topics that we cover already. All right, this one. All right, let's look at this one. And again, these questions can be done in multiple ways because we're on ratio and proportion. I'm basically trying to use that approach to do it. All right, I'm going to use that way to do it, ratio and proportion. Watch this now. This question says, I'm going to use a ratio method to do this and show you, guys. A ratio method I'm going to use. I might show you the other way, speed equal distance over time way as well, and just show you. So I'm going to use a ratio method to do this very question. All right. It says the car is traveling at a speed of 54 kilometers per hour. This is a ratio really, It means in terms of time to distance. Time to distance. That's what it means. It's 54 kilometers per hour. It can be written as a ratio like this. Time to distance. Because it's a constant speed, you can use that as a ratio. Time to distance is 1 hour to 54 kilometers as a ratio. And now I want the distance traveling 2.5 hours. So it means that I want this side to come, not 2.5, 2.25. It means that I want this side to become 2.25. For this side to become 2.25, I need to multiply by 2.25. If I want this side to become 2.25 hours, I need to multiply by 2.25. So like I'm going to take this ratio now and simply multiply it by 2.25. I'm doing it like a ratio. So this side becomes the 2.25 hours that we want it to be. And when I multiply this by 2.25, we'll get the answer that we want. Anybody got that? What was it? 2.25 times this.
Yes, sir.
What you got? Tell me the value. Right there.
I got 1.
Huh? Got 121.5. That's it?
Yeah.
Good. That's the answer now. This is the answer right here. Doing it like a ratio. But then I guess a lot of you would have learned about speed equal distance over time, but that is only when it's going at a constant speed. If it's not going at a constant speed, then you can't use speed equal distance over time. I tell you that from now. So you're doing speed equal distance over time. Let's say we're using that approach. And you want to calculate the distance traveled after this time. So to calculate the distance, we're going to multiply the time across here. So the distance equals the speed times the time. The speed is 54. 54 times the time is 2.25. That's going to give you the distance. Therefore, the distance would be 121.5 kilometers, just to see. So this is using the standard speed equal distance over time approach. The answer is the same. But I said to you, this really can be shown as a ratio. Because 54 kilometers per hour means every 1 hour it was 54 kilometers. That's what it means. You can treat it like a ratio. All right, look at it that way. Can treat it like a ratio. This one says, calculate the time in seconds taken to travel 350 meters. And they give us this information that 1 kilometer per hour is 5/8 meters per second. But again, I can use and do it like a ratio, starting with this information up here. That 1 hour is 54 kilometers. And I want to get what 350 meters is. So all it is, I will want this distance side to become 350 meters. I'm going to do it like a ratio. All right, let's do it like a ratio. So it's like I have a ratio 1 hour to this is what they gave us. 1 hour to what is that now? 54 kilometers. And I want the distance side to become 300 meters. But I want this side to become seconds. I want this side in seconds. Can I see them say the time in seconds? So I want the hour side to become seconds, and I want this side to become meters. All right? I want to do it that way. All right, so I'm going to convert this side to hour to seconds and convert this side to meters to begin with. So 1 hour is 60 minutes and 60 minutes is 60 seconds. So this side becomes 60 times 60 seconds. This side becomes 60 times 60 seconds. This side becomes this. 2, I want this side in meters. 54 kilometers is 54,000 meters. So I've taken the scale that they're giving me and I've now written it in terms of the unit that I want. Because they're asking for 315 meters and I want the time in seconds. So I've gone from this scale to a scale of seconds and meters. What am I doing with this scale now? I want this side to become 315 meters. I want this side to become 315 meters. I can simplify it first, you know. So for example, I can divide down these 2 zeros and cancel out these 2 zeros and all that. But I like to leave the calculation for last. Just do one calculation at the end. I just want this side now to become 315. How do I get this side to become 315? I can bring it down to 1 and then carry back up to 315. And then this side will be the answer that I want. I'm just choosing to do it using a ratio method because that's what we're doing now. All right. So to get this side to go down to 1, I need to divide by 54,000. That's the first step. So I'm going to divide by the 54,000 to get it down to be 1. I want the distance side. The distance side I'm trying to bring to 315, you know. So it's going to become 1 meter. 1 meter when I divide it by 54,000. But I've divided this by 54,000 as well. If you want, you can write this as 3,600, you know. Multiply the 60 by the 60. The 6 by the 6 and get 30. But you can write this back as well and just put everything in the calculator one time. So I'm going to get 60 times 60 divided by 54,000. And I always say to the student, don't work out until the last seconds for 1 meter. And then I want this side to reach 315. So what do I do next? Multiply by 315. Multiply by 315. When I multiply by 315, this side becomes 60 times 60 over 54,000 times 315 seconds to this side becomes 315 meters. So then whatever this works out to now, that is the answer that you want. Let's work this out now. Let me get the calculator and work it out. So I'm deliberately doing it this way, guys. I'm not telling you that this is the only way to do it. I'm just showing you the power of doing some of these questions using a ratio method, where you're simply multiplying and dividing by values to get the information that you want. Very simple, that good method to have. All right, it reduces the complication of stuff. So I'm doing this calculation now on the calculator. So I'm putting a fraction. On top of it, I'm putting 60 times 60. And again, remember, you don't need to calculate the final until you reach a final figure to calculate. But this is S for seconds, you know, that is S for seconds, right? So I'm going to 60 times 60. I'm putting that over 54,000. And then we're multiplying that result by 315. 21 seconds. 21 seconds. So this is 21 seconds to 315 meters. 21 seconds. So the answer right here is 21 seconds. This is the answer. 21 seconds is the time it takes to cover 315 meters using a simple ratio method. What did I do in the ratio method? All I did was multiply and divide by values. That's all I did to get the final answer. Multiply and divide the ratio by values. That's all I did. Initially, I converted the hours to seconds, yes, and converted the kilometers to meters, right? So the 54 kilometers is 64,000 meters, and the 1 hour is 60 minutes, and then 60 minutes are 60 seconds, and it becomes 60 times 60. Then I proceeded to get this side or this side down to 350. And whatever this side is the answer that we want. But okay with that? But all right with that?
Yes, sir.
Yes, sir.
All right. Good. It's a nice way to do it. All right. And see, I ended up not using this information. So maybe next time when I do this question, I'll do it using this information. Convert the kilometers to meters per second squared. To convert these kilometers that they gave us to meters per second squared. And all you have to do to know what the speed is. So since I give you this again is like a ratio, you know. Since I give you that, right? Let me do it over here. Let me do it over here. Let me do it the other way over here, just for you. All right? Let me just do it. So they give us this 1 kilometer is 5/8. Let's look at it. So the 1 kilometer speed, 1 kilometer per hour speed, they're telling us is the same as 5/18 meters per second. Because they want us now to be working in meters and seconds. But it's 54 kilometers they gave us, you know. So we need to know what 54 kilometers per second per hour is in meters per second. So I have to multiply this by 54. Multiply by 54. I want to know what the speed of 54 kilometers per hour is. So we're going to see that 54 kilometers per hour is the same. I multiply this now by the 54. Let's do it and see what we get. So it's 5/18 times 54. And we get 15. So that is 15 meters per second. So this is speed now, 15 meters per second. If you're using a method of speed equal distance over time again, I want to say speed equal distance over time. We're trying to find a time. So we're going to multiply up the time and divide on the speed. So it means that the time is equal to distance over the speed. What is the distance that asks us about? 315 meters. So distance is 315 over the speed. The speed is 15. You're going to get 21 just to see. 21 seconds just to see. You can try it over here. Look. 315. 315 divided by 15. Save 21 seconds. So anyway you do it, you get a correct answer, we're good to go. But I deliberately wanted it to show you using a ratio method. Right? That's why I did it this way for you. I want the topic of ratio now. But that is it. Right? And this one did not depend on you knowing that speed equal distance over time. This one is just ratio. You're just trying to get this side to become 315 meters. That is all. That's what it is about. And you get this side in seconds. All right, that is what it was about. All right, buddy, go to that so far. Buddy, okay?
Yes, sir.
All right. We'll come to this one now. Here's another example of question where they want us to get out the units. They don't want the units, you see? It said, write the following scale in the form of 1 to x. So in other words, they don't want any unit in it. So in order to divide by the units, you have to make sure both sides come to the same unit of measure. All right? So in reality, this is 1 millimeter. So it's 1 millimeter. They're telling us as a ratio, but I'm not going to write equal. I'm just going to put a ratio. I'm not going to write equal, but equal is not true. It's a scale. So they should really have the colon there instead of the equal. All right? Should have the equal there. It's a colon. So it's 1 millimeter to 1 meter is a scale. But 1 meter is 1,000 millimeters. If you look at the kill him there, mister, don't commit murder again. Don't use the millimeter, you know. All right, here says the meter. So one of this is 1,000 of that. All right, 1,000. I'm going to change this 1 meter here to 1,000 millimeters. So it becomes now 1 millimeter to 1,000 to 1,000 millimeters. And you can divide both sides by the millimeter now. Remember, I said it can divide by any constant value or any constant unit of measure. So when they divide by the millimeter, they divide it by the unit on both sides. So cancel off on both sides. So in terms of the values, it becomes 1 to 1,000. So in this case, the x is equal to 1,000 up here. That is it. So must write it like this. Write it in this form. We have done it here. It's known that form 1 to that. Let's look at this one again. It shouldn't have equal there. It should be 2. So what they really give us here is 2 centimeters to 6 meters. That's a scale. All right. So again, we want the two sides of the same unit. This we need to bring this down to 1. Right now, we can divide through by 2 and bring it down to 1. So let's divide through by 2 first. Divide through by 2. And we're going to get 1 centimeter to 3 meters. We have to get both sides of the same unit. This is a bigger one. So I'm going to show that the 100 centimeter make a meter. So 3 meter is 300 centimeters. So we're going to have 1 centimeter to 300 centimeter. Okay, now divide both sides by the centimeter. I can divide by any constant value or any constant unit of measure. So divided by the centimeter. Divide by the centimeter. This side becomes 1. And this side becomes 300. And that is the answer. The x is 300 up here. That is it. What do you go to that?
Yes, sir.
All right, beautiful. Anything else? Oh, here's another map and scale question. All right, let me take this off. Here's another map scale question. This time it says, they give us the scale, right? 1 to 2,000. It says, the map shown below is drawn on a grid of 1 centimeter squared. P, Q, R, and S are 4 tracking stations. Scale of the map is 1 to 2,000. So it's like 1 centimeter to 2,000 centimeter, if you're working in centimeter. But the map size would be in centimeters. The map, you measure on the map in centimeters. You want to measure on the land, either in meters or kilometers. You have to read the question to see which one they're using, right? Let's see. It says, determine in centimeters the distance from Q to R on the map. That's right here. So 1 centimeter squared, so we're counting out the grids. So it's 1, 2, 3, 4, 5, 6. 6 centimeters. It's almost every one of these questions, they always ask for a distance on the map, right? Right? Q to R. This point over to this point is 6 centimeters. Let's just double check it again. 1, 2, 3, 4, 5, 6, right? So that's 6 centimeters. 6 centimeters. I have a centimeter there for us. It said determine by counting squares. See, determine by counting squares the area in centimeters, in squared centimeter. This means centimeter squared. That's what this means. Squared centimeters of the plane PQRS on the map. Now, this plane this time, the trapezium, you can see that. Right? You can actually break it down here into a triangle and a rectangle and add them up. We can also treat it like a trapezium, where these are the parallel sides, and this is the distance between the parallel sides. All right, whichever way you want to do it, you know, there's a count squares. If I'm counting squares, I have to treat this like a whole section first. This should be a 3 by 4, so total in here is 12, but I'm dividing by 2, so this is 6. So right, this is 6. Or can recognize it as a triangle. And this is 3, and this is 4. So we're doing half 3 times 4, 6. All right, so this triangle here is 6 centimeters squared. And then this is 1, 2, 3 by 1, 2, 3, 4. 3 by 4 is 12. So here is 12. The total area is 12 plus 6, which is 18. But I could also count off. I'm still counting now, guys. So by counting square, we are still counting. Count off here, and it's 3 centimeters. Count off here already, and it's 6. Now count off this perpendicular distance between them, and it is what? 4. 1, 2, 3, 4. And so the area becomes half the sum of these two parallel sides multiplied by this distance between them. Right? So these are counted. So we have counted squares. So I'm going to say the area becomes equal to area on the map is half the 3 plus the 6. That's the sum of the parallel sides. That's this 3 plus this 6. Those are the parallel sides. Multiply by the distance between them, which is 4. That works out to be this is about 9. All right. Half of the 4 is 2. 2 9s 18. So you get the same 18 centimeters squared. So I guess whatever method they use, but I said counting squares. Some people feel like they have to actually count individually the squares inside here. I don't think you have to, because my point is you have to count these in order to know that this is 4. So you have counted the squares. You have to count these in order to know that this length is 3, and so on. So I'm still counting squares to get those dimensions. Because I recognize it as a trapezium, I can use the area of a trapezium. All right, next part says, calculate the actual distance in kilometers between Q and R. All right, so I want to use the scale now. But I just start, I want it in kilometers, right? So we're going to start out with the scale in centimeters. So the scale is 1 centimeter to 2,000 kilometers. That's what they gave us up here. No, centimeters, sorry, 2,000 centimeters. Centimeters to centimeters, sorry about that. We need to convert this side now to kilometers, because I want it in kilometers. All right, so we're doing the scale. We're gonna convert this to meters first by divided by 100. So 1 centimeter to divide by 100, we'll get 20 meters. Why did we do that? Because remember that 100 centimeter is the same as 1 meter. So it divides by 100 to get the meters. Then now, 1,000 meters is equivalent to 1 kilometer. So to go from this to kilometer, we'll divide by 1,000. So it's going to become 1 centimeter to divide this by 1,000, move this 1.3 places to the left. 1, 2, 3. Putting a 0 inside here. From 0.02 to 0.02 kilometers. And what they want the distance QR. Distance QR was 6, right? So if I multiply this scale now by 6, multiply this scale by 6, that's what QR is. And so we get 6 centimeters. So multiply this by 6, we get what? 0.6212 kilometers. But all right with that? Very good.
Yes, sir.
Yeah. Yes, sir.
I'm like, I'm not sure, so not sure.
Yes, sir.
All right. So this is the answer right here. 6 centimeters is 0.12 kilometers. That's the answer. I don't want it. Calculate the actual distance That's the distance of QR. All right, QR on the map was 6 centimeters. I will convert it to these kilometers. That is it. Next part says calculate the actual area now in square meters. So now they want meters. All right. Remember, if you want the area scale, I'm gonna show the two ways again to do it. All right. I'm gonna show you the two ways that we can use the distance scale if you want. So distance scale in meters. This is the distance scale in meters, and I'm working in meters now. All right. So distance scale in meters. Remember, the distance scale in meters is 1 to 1 centimeter to 20 meters. That's a distance scale with the units on it. This is for distance. For area, you're going to square this. So you're going to get 1 centimeter squared to, when you square this, it becomes 400 meters squared. That's a scale for area. Area scale is up here, the distance scale. So we can use this area scale now to calculate the actual area in meters squared. What was the actual area again? The actual area was 18. Right? So using that method, starting by saying 1 centimeter squared to 400 meters squared, and actual distance, actual area was 18. We multiply this ratio by 18. This side becomes 18 centimeters squared to, I will work this out, 400 times 18. Somebody can tell me that? Somebody can tell me 400 times 18? All right, that's 7,200 meters squared. This is the answer. That's the actual area. All right. Or we could use, as I said, can use this. So all right, we're going to use the distance scale in meters. The distance scale is meters 1 centimeter to 20 meters, right? That's a scale. What is now? The 18 centimeters squared. The 18 centimeters squared. It's the same as, it's 18 times 1, you know, same as 1 centimeter times 18 centimeter. So 1 centimeter is 20 meters. And the 18 centimeter, you have to multiply this now by the 20. All right. Do we have any dimension we could use? A 6. Oh, whenever I use a 6, we use the kilometers. All right. Let's do it down here. So I could change this 1 centimeter to meters. So this is 20 meters times, this one multiply this 18 by 20. 18 times 20 meters. That don't look right. That don't look right. Let's see. 1 centimeter is 20 meters. What is 18 times 20? 36, right? You know? Correct. Multiply this out. 2 times 18 is 36. It becomes 20 meters times 360 meters. That's what I'm multiplying. 20 times 360, 360. The same thing. 7,200 meters squared. Meter times meter is meter squared. 20 times 360 is 7,200. Students, understand this method, this calculation? Instead of using the area scale to do it, we break down the 80 meters squared into the 18 centimeter squared area into 1 centimeter times 18 centimeter. And we're using the distance scale. 1 centimeter is 20 meters, but but the 20 meters, no, sorry, but the 18 centimeters on the map becomes 18 times 20 based on this scale that I have here. And this works out and give us the area on the map. If you want to use the area scale by squaring the distance scale and then get it, fine. But I'm showing you that you could also break the area into 2 dimensions. I work it that way as well. Very good?
Yes, sir.
All right.
Yes, sir.
I think I gave you one more question, right? One more question there was, I believe. What was it? It was 2014, question 1. Part of question 1. Let's find that one. Then we call it a day. Starting a new topic tomorrow, guys. Get yourselves ready. It's gonna be fun, and more fun. So get yourselves ready. It's gonna be nice and easy. Question 1. Question 1. Is it this? Which paper told them? It's 2024, man. 2024. It's 2024. Do I have it in this device? Yeah, so it was shot. 2024. I'm not going to notes if I have it. I don't have just the paper in here. Let me see if I can find it somewhere down here. 2024, question 1. This is the paper that's gone the other day, guys. 1B, right. There you go. So I'm deliberately doing it using a ratio method. All right? It's a ratio question. It says, what is that? Mahendra and Jeha share this amount. So that's a total. That's a total. So we need to extend the ratio to show a total, right? In the ratio 7:5. So how much more? That's a difference, you know. How much more? That's a difference. So I'm going to extend the ratio to show a difference. I need to include a total on the ratio because of this. And I also need to show a difference because I asked me for a difference. Money does Menja get than Jeha. So it's the difference between these two in the parts, right? So I'm going to set it up like this. So it is Mahendra to Jeha to the total. I'm extending it to the total to the difference. Put these two parts that I've extended it to in red. All right. So remember now it is 7. Total parts will be 12, extending it to the total and the difference. Total parts will be 12, the difference will be 2. 2 is how much more. So if we want to find how much more, we need to find out what this value is. When the total becomes that figure. You know, all I need to know is for the total side to become this. And I see what the difference is at that time. I don't even need these figures over here. I don't need them again. I can just work right here so alone. Bring the total side to this, and whatever the difference side is my answer over there. But to double check, we can write these out as well. All right. So the question is, what do I multiply 12 by for it to reach this? I can know by dividing it. I can divide it and see. All right. I can divide it and see. I can divide, use the calculator. Let me leave it. Use the calculator and divide 7, 20, 7224 divided by the 12 to see what you have to multiply 12 by to get that. All right, let me see what that is when I work out. What is that number? That number is 7224 divided by 12 is 602. So I have to multiply this whole ratio by 602 for the total to show me the actual, and then all other figures will be the actual figure that they are supposed to be. So I'm multiplying by 602. So I'm multiplying by 602. Remember about the calculation up here. So the 7224 divided by 12 is 602. That's what I'm multiplying by, 602. And it shows me how I got it. Right? Because I want this column to become 7224. All right, so when this becomes 7224, what does this become? It becomes this times 2, which is that something 4 and 120. That's what it becomes. I multiply this by 2. So this is the answer now. That's the difference in money. Right? This is the answer right here. That's the difference. So I've found it already. That's the answer. I just wrote these out and just double check it. I multiply it by the 602 and multiply it by the 602. Everything should be consistent. I will be consistent for sure. So when I do 7 times 602, let me shift these over a little bit. Let me shift these over. Ouch. Shift these over a little bit. All right, shift this over as well. I'm gonna put in for these figures. You don't need them, you know. I've the answer here already, you know. Basically done, you know, but I was putting it in for information, right? So it is 7 times 602. 7 times 602 is 42142. And I'm doing 5 times 602 next. 5 times 602. That's 3010. 3010. And if the difference between these two, we're gonna get that figure anyway. All right, so the answer, this question is this figure in dollars. That's the answer. But okay with that? But good? So question
Yes,
gave
sir.
us a total, so extend the ratio to show total. It asks us for a difference, so extend the ratio to show a difference. Remember, you can't extend the ratio to show products and quotients, right? We have to do additional stuff if you use products and quotients. We can extend the ratio to show add some of the values or difference of the values. That's what we can extend the ratio to do. And most questions that that's what they'll ask you about. Some of the values or the difference of the values. All right, you can extend the ratio to on those values and those. This part says, am I doing this part as am I doing this question as a proportion question? Ratio proportion. The ratio says the present population of Portsmouth is 550,000. It's expected that the population will increase by 42%. It says write the number in standard form. We shouldn't be doing this yet, you know. Standard form is that we need to just get the decimal point right there between the fives. So we must have one non-zero digit before decimal point. So it becomes 5.5 times, and all my decimal places, we have to move it back. 1, 2, 3, 4, 5. So it's 5.5 times 10 to the 5th power. That's what it is. I remember it's a big number, so this power has to be a thing. I'll explain this some more with the topic. I don't want to get into explaining this now, but that is what it is. All right, I don't want to get into explaining. I'll explain it when we get to this. We're not really doing this now. But that's standard form for that number. And some calculators actually can give it to you. We tell it scientific notation, it will give you a scientific notation. All right. So it's 1, 2, 3, 4, 5. That's correct. All right, this down here now says calculate the expected population in 2030. So if you're gonna increase by this amount, what some person would do, they will calculate 42% and then add it on back. But they don't want the increase in it, they want to know what the population is gonna be. But the population is gonna be 142%. But it's gonna be what was there before, which is 100%, plus 42% more. So the population is gonna be 142% of what was there before, 550,000. That's what you're working out. 140, 142, yes, 142%. Otherwise, this work out is the answer. And 142% is 142 over 100 times 55. 55,000, yeah, 550,000. That's the population after increase by 42%. It becomes 142% because it has increased from 100% to 142%. So the increase is 42%. So 142 divided by 100 times 550,000. I'm getting 781,000. It's going to be the population after we increase it by 42%. All right, the population is not going to be 142%. I think this is the question I wanted us to get to do. I don't know why I put these in there now. Should have left off C. Because C is not really a ratio. This is one that I want us to do. I set this in the exam just gone the other day. It says the graph below can be used to convert between US dollars and Eastern Caribbean dollars. So the graph. So if you have the US dollars, come up here and read it down to get the EC. And if you have the EC dollars, you read it up and come across to get the US. All right, let's see what it says. It says using the graph, convert $2 US to EC. All right, so it's the $2 here. Okay, I'll come across and read it down. But it's very important that we understand the scale first before we're going to do anything. In other words, we want to know what each of these little lines represent. Or you can know. So they have 5 gaps over 1 unit. 5 gaps, 5 intervals. 1, 2, 3, 4, 5. 5 small spaces over a unit of 1. So each of these small spaces becomes 1 is the total divided by 5. That's 0.2. Right? So it means that, for example, here is 1.2, here is 1.4, here is 1.6, and here is 1.8. All right, so I establish that. But each of those lines, each of these little lines is 0.2, right? 0.2. Let me put it here, so 0.2. All right, so look at the graph now. It's $2 we want. So when I come across on a graph, let's get the reading at $2. So on this line, and it's coming actually in between here. I want to be accurate. It's coming right in between here, so. Remember, right here, it'll be 5.2, and right here, it'll be 5.4. But exactly in between them, it's 5.3. So this is 5.3 right here. 5.3, which is $5.30 EC dollars. That's the answer. $5.30. What do you understand that? What do you go to that?
Yes. Yes, sir.
Remember, you have to read the scale, the smaller dimension of the scale, you have to read them off, determine what they are. All right. Next part says, convert 70 EC dollars into US. Trouble is, 70 is not on the scale. Don't go all the way up to 70. It stops at 10, as I can see there. Remember, the same proportion. So what we can do then is see what EC $7 is first to US dollars. And then multiply by 10 to get $70. All right, but look for 7 in US dollars. All right, so let me do this. And then multiply by 10. All right, so let's do for 7. 7 here, so let's get the reading again. So starting at 7 now, 7 EC, I want to find US. So come up on the graph. Right there, so. And you come across. This is the line that we're on. And here going up by 2 as well, right? 0.2, 0.2. So this point right here is 2.246. 246. So it's 2.60. And this is US dollars. All right, $2.60. That's what $7 is. $7 is $2.60. Let me write it here. US $2.60. It's 10 you want, 70 you want. So we multiply this by 10 to get the 70. And take this and multiply it by 10. Multiply that by 10 now. This becomes 70 that you want. Multiply this by 10, we get $26. So just $26 is the answer. And that is it, guys, for today. I'm going to see you all tomorrow and Monday. It's going to be fun. But good?
Yes, sir.
Yes, sir.
All right. So remember, anything that you got wrong, you need to redo it. I'm going to send the video to the group right away. So you can look back. Any question you got wrong, you need to redo the question. All right. That is always the plan. That is always the aim. That's what you do. We're trying to aim for perfection. It's progress before perfection. We're taking stages. We'll keep working at it constantly and consistently. All right. So see you all this week. This week is coordinate geometry week. 1 week of coordinate geometry. All right. So I'll see you tomorrow on Monday. Bye, everybody. I'm going to send the video right away. Anything you get wrong, work it over back. If you never do it, go and work it again still. Watch over the video. Try over the question. And some of the other ways, just some of the questions, try and do it. It helps you. The mathematics will improve. When you have multiple ways, multiple methods of doing questions, the whole mathematics will improve. We have to keep practicing. Remember, mathematics is a doing subject. You can't learn mathematics by watching videos only or just reading information. You have to actually do questions. All right, so see you all tomorrow. Bye, everybody. I'm going to end it now.
Yes, sir.
Okay, bye-bye.